Please students! From Victoria Institution, batch 2021. And today, we are going to demonstrate an experiment to show the different types of damping.
Basically, what is damping? Damping causes an oscillating system to lose its energy due to the resistive forces of the surrounding medium. Therefore, eventually the oscillating system will return back to its equilibrium. There are three types of damping: light damping, over damping, and critical damping.
Hi, I'm Rauda and this is my friend Lo. We will demonstrate light damping. So I'm going to demonstrate oscillating system without damping. So you can see here the system is in equilibrium. So when I displace it, you can see the system oscillates at a constant amplitude and it will never stop.
When the system is immersed in water, this is the equilibrium point when the system immersed in water. When it displaces, the amplitude of the oscillation decreases with time before it stops. Hence, it shows a light damping.
Okay, so the oscillating system can be represented by this graph.
Hello, I'm Kevin. This is Pang. We are going to demonstrate critical damping. So what is critical damping? Critical damping is defined as the condition which is damping returns as quickly as possible to its equilibrium position. To demonstrate system without damping. And then I'm now going to insert the system into a solution which is honey. So what can we observe from the experiment is basically the system immediately stopped due to the damping force of the honey, and hence this shows that this is a critical damping.
Hello, I'm Abhishek, and now I will be demonstrating you a heavily damped system, or also known as over-damping. So, over-damping is when an oscillating system is in a situation where the resistive forces are so extremely large that it takes a very long time for the system to return back to equilibrium. Now, to demonstrate this, I have a few examples here. So both of these are liquids that have such a high resistive force, and when an oscillating system is introduced into these liquids, we will observe heavy damping. So first of all, I'm going to demonstrate to you how it looks like without any damping at all. So as I displace the mass, you can see that it oscillates with a constant amplitude for a very long time. And now, to illustrate to you how heavy damping works, I have jelly. So, first of all, I'm going to mark the equilibrium position on this. Okay? So this is the equilibrium position. Now let us see whether or not the system will reach this equilibrium position. 1, 2, 3. As you can clearly see that the system is not at its equilibrium point which we have marked earlier. This is because jelly is very thick, and thus the resistive forces are pushing against the weight of the mass, so that it hasn't returned to its position, equilibrium position yet. But it will eventually reach the position, but after a very long time. Now we can also see this in a different liquid called cornstarch. Okay? In cornstarch, you can clearly see that when I drop the pendulum into it, you can see that the resistive forces are so hard that it appears to have stopped the pendulum on its own. 1, 2, 3. You see that? The equilibrium position is somewhere at the bottom here, if you compare it with the jelly, but the pendulum hasn't reached the same position yet. This is because the cornstarch also has very high consistency. So to further illustrate here, we can see that here we have the graph of an overdamped system. So you can see that this is the displacement time graph for overdamped system. And when you insert the system into a heavily damped liquid, you can see that it takes a very long time for the displacement to reach its equilibrium position at 0. So, this is how heavy damping works, or also known as overdamping. If you have any questions, you can comment down below.
Thank you for